Hello, class. Going to do some lecturing here on section 1.2, which should be a review of solving quadratic equations. Quadratic equations, especially in this class, are very important. It is sort of the foundation of, especially when we get to chapter 5, which is this idea of calculating roots of a higher order polynomial. And so the understanding of probably the second simplest polynomial, which is a quadratic, is really important to get a nice foundation to be able to move up to more complicated equations. So what we're going to do in this lecture is to start with, let me share my screen again of the whiteboard. And the idea of let's get some definitions done here for you and being able to talk about different solutions of quadratics. So the idea of a quadratic is an equation would be set up as y equals ax squared plus bx plus c. And that's the definition of a quadratic, where a, b, and c are real numbers. And those x's obviously are variables. And the idea is that you don't have a quadratic unless the a value is not equal to 0. Because if not, the x squared goes away, and so it won't be a quadratic. And so what we're going to be focusing on is this idea of setting y equals 0 or setting the equation equal to 0 and solving. And the idea with this is that if you took a look at a graph, when the value of y equals 0, you end up right on the x-axis. So what we're going to be doing is solving these equations where if you graph the thing, it's where it would cross the x-axis. And so in the math world, we call those x-intercepts. We also sometimes call them roots or zeros of the equation. And in a quadratic, and any polynomial, and we'll talk about that in detail in a few more weeks, the degree of this polynomial is its highest exponent on the x, which is 2. And so the degree of the polynomial will give you all the possible answers for the roots or x-intercepts of this equation. So we could have 3 possibilities. There could be 2 solutions, and that would be the most. There could be 1 solution, or no solutions. And what we mean by the solutions now is these are going to be real numbers. And we're going to talk about complex numbers a little bit today and in much more detail next week when we get into the next section about complex numbers. So the idea here is let's take a few different scenarios. And what we're going to do is walk through, let's say, 5 different scenarios of solving the equation. And let's say scenario number 1 is this idea when the c value equals 0. And remember, if we had x squared plus bx plus c, that means that this value actually goes away and would be 0. So an example of an equation that looks like that would be y equals x squared plus, say, 6x. And so now if you want to solve for the roots or the x-intercepts of this equation, what you do is you set y equals 0. And so the equation would be x squared plus 6x equals 0. So then the strategy of solving this equation, I think the simplest and most straightforward, is the idea of factoring. And because the constant term or the c value has gone away, you always have a common factor of x in both the x squared factor, there's two x's in there, right? And the 6x factor, which is 1x. So if we factor this out, we'd get x equals x plus 6, and that would equal 0. So then the idea in this case is that you have two factors multiplied together, right? You have this x as multiplied by x plus 6. So if either one of those factors are 0, 0 times any number always gives you 0. So that's kind of the strategy with regards to getting the solution. And so the first thing would be to take this x and set it equal to 0, and that would be one solution. And you would see that when the c value is 0, that's always going to be one solution because you could always factor out the x. The second solution would be x plus 6 equals 0. Bring the 6 to the other side, and that would be minus 6. So you can see that when you plug minus 6 into here, you get minus 6 plus 6 is 0. So that would be our second solution. So in this case, in this scenario number 1, you do get two unique real number solutions, x equals 0 and x equals minus 6. Okay. So scenario number 2 that we'll talk about. And scenario number 2 that we'll talk about is this idea of when the b value in the equation equals 0. And so that would happen is, remember that we have this scenario here. And then when the b value is 0, that goes away because 0 times x, it doesn't matter what x is, it always will be 0. So an example of this would say, let's take this one first. Y equals, say, x squared minus 9. So in this scenario, the idea again is that we're going to set this equal to 0, the y value equal to 0, and solve for the roots of the equation. So the way I like to solve this is I will bring the minus 9 to the other side of the equal sign. So you add 9 to both sides, and you would get x squared equals 9. And so this is the strategy of you want x equals something. So how do we get rid of the square and the x squared? Well, basically, if we take the square root of both sides, that would make x squared equal to x. But one thing that you want to remember is that when you take the square root of both sides of the equation, there's a possibility of two solutions, the positive and the negative solution. So in this case, we have plus or minus the square root of 9, which is 3. So the two solutions are minus 3 and plus 3. And so just to double check that, remember 3 squared equals 9. And while we have two solutions, what does minus 3 squared? That also equals 9. Remember, when there is an even number of negative signs that you multiply together, it turns into positive. And when there's an odd number, it turns into negative. So that would be one example with regards to b value equals 0. Well, let's do one more. And so this strategy here would be, let's take x squared plus 9, and we'll set that equal to 0 and try to solve. So again, this is the same scenario where we have the b value equals 0. See what we get. So you do that same strategy, and you move the plus 9 to the other side. So you subtract 9, and we get 9 on this side. And then you take the square root. So you would have x squared equals the square root of minus 9. And remember, you want plus or minus out here because there's two possibilities. So what ends up happening in this scenario? Well, if you remember that one of the things that you can't do with real numbers is take the square root of a negative number. The two most important things to remember: no square root of a negative number. It's not a real number. It's a complex number, which we'll talk about next week. And also the other thing you can't do is you can't divide by zero. Those are the two kind of main aspects of dealing with arithmetic and real numbers. So in this case, we have no real solutions. So here's a scenario where you have no solutions for the equation. So that is the first part of the quadratic review in section 1.2. I am going to stop the recording now, and we'll jump back in on a separate recording to talk about quadratics a little bit.